Okay, so today we want to talk about how to convert from polar to rectangular coordinates. For today, and again, we're just going to do the ordered pairs. We're just going to look at the point. So what we can do, and now these same rules we can use to also convert equations if we get into that. But for now, we'll just do this. So here I have just a coordinate plane. This is sort of where our equations come from. Sometimes it's nicer to do this than just have to memorize things. So I have this point. It could either be in rectangular form, it would be xy, or in polar form, it would be r theta. I went ahead and put a segment between the point and the origin, or the point and the pole, because what this will give us then is if we think about the right triangle formed by this point, this length is x, this length is y, that length is r, and the angle formed with the positive x-axis or the polar axis, and that connector between the point and the pole, or the point and the origin, would be theta. And again, these equations will work in all three quadrants. It's easier to hash them out in the first quadrant. We'll have to make a little adjustment for finding theta, just like we did with vectors. So the first question we want to answer here on our packet is to write x in terms of r and theta. Well, let's see, x, we have a right triangle. X is adjacent, r is the hypotenuse, theta is an angle. So we could say that the cosine of theta is x over r, and we'll use this equation to help us find x. So for this one, we can rearrange it and get x equals r cosine theta. So that is what we're going to use. If we're given a polar coordinate with the r and the theta, we can find its x coordinate, right, by using this little equation here. For the sine of theta would be y over r. Same idea, right? Would be y over r. And then y would be r sine theta. So that's how we'll find the y coordinate if we know r and we know theta. So to kind of summarize there, to convert from polar to rectangular, we do, the xy coordinate will be r cosine theta, r sine theta. So that's a pretty quick conversion there for that one. For our first example here, we're asked to find the rectangular coordinates. And I always like to just say r theta equals. Now, hopefully I noticed that 2 pi over 3 should indicate that it's a polar coordinate, but this really indicates, right? So to do that, to find the rectangular coordinates, or the xy coordinates, we get that xy will equal 4 cosine 2 pi over 3 and 4 sine 2 pi over 3. And then we just have to evaluate this. So we'll get 4, let's see, cosine of anything over 3 is 1/2, but 2 pi over 3 is in the second quadrant, correct? So that would be -1/2. So 4 times -1/2. And then sine is positive in the second quadrant, would be radical 3 over 2. So that's going to be -2, 2 radical 3. And that would be our rectangular coordinates. We okay there with that? Everybody remember all your fun with trigonometry things? Now, well, we'll look at some ways that you could check that, but let's go ahead and go back to the same picture here and use it to convert the other way. So we can keep this, we'll keep that there, I guess. But let's go ahead and think about, are everybody good on this one? Yeah, so we'll get rid of that. All right, so to convert the other direction, so this is where we would be given a rectangular coordinate point, and then we have to find the r and the theta. Well, we could still use this same picture, right? So if we look, if we know x and y, r is just the hypotenuse of a right triangle, correct? So to find r, it's just going to be the square root of x squared plus y squared. You might think back to vectors. When we found the magnitude of a vector, we did the square root of a squared plus b squared. This should seem like the same stuff, just you're using x's and y's instead of a's and b's, because it is the same stuff. Now, the next thing we want to do is to find theta. And here, because we're going to have to use an inverse trig function, I'm going to recommend that we find theta bar. Okay, so for here, just call that theta bar, I guess would be the angle between the x-axis and the hypotenuse of our triangle. Theta bar, we said, would be the absolute value. In this case, it would be y over x. Right, y would be the opposite, x is the adjacent, theta is the angle. So we can set this up, and this will let us find our values there based on that. Does that seem good there? Again, same equation. Now, what we'll have to do, so this is how to convert from rectangular to polar, would be that idea there. So again, here's from polar to rectangular, here's from rectangular to polar. Our next example would be to convert 2, -2 to polar coordinates. So with this, now, all of them, it's never a bad idea to make a sketch, but this is really important to make a sketch because we're dealing with theta bar. We're going to have to adjust to figure out actually what our theta is. So in this case, if we think about the point 2, -2, it's going to be down here, correct? Down in the fourth quadrant. So we know it's going to be some value between 3 pi over 2 and 2 pi. We're going to have to make an adjustment, which is not a significant adjustment. It's one we've made a lot of times, but it's just we want to be aware of that. So the first thing we can do is we can find r, which is the square root of 2 squared plus -2 squared. That was r squared, wasn't it? Or no, that's r. I have the square root there. So that's going to give us the square root of 8. We should rationalize that to get it to be 2 radical 2. Right? Remember that 8 is the same as 4 times 2. So the square root of 8 is the square root of 4 times the square root of 2. And then we have the tangent of theta bar. And I'm just going to do the y value with the absolute value of the y value over the x value. So that gives us that theta bar is the inverse tangent of 1. So theta bar would be pi over 4, because we know the tangent of pi over 4 is 1. Now, we need to still place it in the fourth quadrant, but we know if it has a reference angle of pi over 4 and it's in the third quadrant, that tells us that theta would be 7 pi over 4, or some version of that. You could say negative pi over 4 if you want to. I usually stay between 0 and 2 pi. So we do that one. And then our coordinate would be r theta would be 2 radical 2, 7 pi over 4 would be how we would get that answer there. Now, a great check is just to go back and convert it back into rectangular form. It's a really easy check. So just do 2 radical 2 times the cosine of 7 pi over 4. Right, which, so I can show you that. So to check it, x would be 2 radical 2 times the cosine of 7 pi over 4, which is 2 radical 2 times radical 2 over 2, which just gives us 2. And then y would be 2 radical 2 times the sine of 7 pi over 4, which is 2 radical 2 times negative radical 2 over 2, which is negative 2. So a very simple challenge to do. Okay, and for our last example here, sort of an application. Radar detects 2 planes at the same altitude. Their polar coordinates are 8, 110 degrees, and 5, 15 degrees. And then we want to sketch the locations and then find the distance between the planes. So I'd guess at the airport probably, I don't know. But wherever the observer's at, we're going to call that the pole. I think on your note sheet you actually have a polar coordinate plane, but it's not really even that helpful to do these problems. But here we have this point 8, 110 degrees. Now I just know that's a little bit into the second quadrant, correct? So what I'm going to do here is, because I'm probably going to need to use that length 8, I'm going to go ahead and draw a segment. I'm going to put the point up there for the plane. I'm going to label that length as 8. And then I know that this angle will be 110 degrees. And then the next one is at 5, 15. So 15 degrees is just in the first quadrant here. So that would be 5, and this angle here would be 15 degrees. So now if we think about, that would be their locations, right? But if we think about what we're looking for, we want to find the distance between these 2 planes. Go ahead and call that D. So as we look at this, we have a triangle, right? We know 2 sides. Can we find this angle in here? Yeah, if 110 is the whole thing and we take 15 away, so this angle itself would be, I'm not sure those are great diagrams, but this angle would be 95 degrees, correct? So this is a side angle side case. It's not a right, if it was 90 degrees, it would just be right triangle trig, which we could just do the Pythagorean theorem. It's not, we're going to have to use the law of cosines. Okay, but we should know that, we just tested over that. So we're going to say d squared, which is the unknown side, equals 8 squared plus 5 squared minus 2 times 8 times 5 times the cosine of 95 degrees. And then from here, we'll go ahead and type this into our calculator and square root it. Let me double check. I have an answer, but I want to make sure it's right. Okay. Ooh. Oh, okay. I was in radian mode, so I got the wrong answer. Be very careful. I have 9.8, so D would be, I'm assuming it's in miles, but whatever it would be, it's 9.8 units. Okay, so by knowing how to plot polar coordinates, recall a little bit of the law of cosines, we're able to find that distance pretty easily. To be honest, when I first looked at this problem, I thought, geez, am I going to have to put them in rectangular coordinates and break out the old distance formula, which is a formula that it's just based on the, it's one that we know, but it wouldn't have been a lot more difficult. Where here, with some things that we've learned, it made it a lot nicer there. Okay, so that's just an application of how we could use this.